Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahartethstrcourses. Here I am with the most awaited part 3 of modern physics. I know that you all had to wait for a long time for this class. Apologies from my side for that because I got a bit occupied with paid classes and then other ventures as well. Anyway, I am here with this class of part 3 modern physics, and this class will be a very useful class not only for Hstr aspirant but also for KVS PGT aspirants also. Okay, some portion of the class may be useful for TGT aspirants, but full class will be surely useful for KVS PGT aspirants. Okay, so here is the syllabus of Hstr chapter modern physics. Before proceeding with the syllabus, I want to just remind you all, if you are new to this channel, please do subscribe to this channel and please hit the bell icon so that whenever I upload the new classes, you will get the notification in your YouTube that I have uploaded the new class, and you can watch the class as soon as I upload the class. Okay, so please do subscribe to my channel and also share this class among other Hstr aspirants and other aspirants who are interested in writing teacher recruitment examinations like Karnataka TET, KVS, Common TET, because my channel is dedicatedly made for Hstr type other teacher recruitment examinations. Okay, so you will find many classes in this channel based on GPSTR, Karnataka TET and Hstr. Okay, even you will also find one or two few classes for KVS also. Okay, so let us start with the class. In the first two parts of modern physics, I had covered this portion which I have underlined here. I have discussed atoms, constituents of atoms and their properties, atomic number, mass number, nuclear chain reaction, nuclear fission, fusion and their applications, and we have also discussed radioactivity, alpha decay, beta decay, gamma decay, and half-life and mean life period and problems based on those. And also we have discussed what are isotopes, isotones and isobars with examples. If you have not watched those two classes, I will give the link of those two classes in the description. Please watch those two classes as well. Okay. Now in this class, what I am going to discuss is about atomic models, the Rutherfords atomic model, Bohrs model and Thomson model. Actually, as per my initial plan, I had to finish the mass energy relation, mass defect and binding energy and problems based on that also in this class only. But then I dropped that idea because atomic models is a very important topic, and it is giving you the basic and historical knowledge about the idea, the concept of atom came up to us. Okay, so it will become injustice with atomic models if I include other topics in this class. So I have decided that I will make another part of this chapter where I will discuss mass energy relation, mass defect, binding energy and problems based on that. Okay, so in this class purely I am dedicating this class only for atomic models. We will be discussing Thomsons Model, Rutherfords Model and Bohrs Model in this class, and this class is going to be a very important and useful class. So please tune in till the end of this class and try not to skip any portion from this class. Means try not to forward any of the part from this class, because each and every point which I am going to discuss in this class is going to be very useful, and I am sure that one question will compulsorily come from this part of the class in Hstr. Okay, so let us start with the atomic models. So first of all, see here they have not given the atomic models in order. This is not the actual chronological order. The actual chronological order of these models is actually this. Thomson's model was the first model, then Rutherford came up with his model, Then Niels Bohr came up with his model. Okay. Now this is the chronological order, unlike what is given in the syllabus. Okay. So I will follow the actual chronological order without following the syllabus. Okay. Because I want to build up a nice story, and there is a lot of connectivity between each models. So please tune in till the end of this class, because this class is going to be very interesting class. This atomic models, no, we have read this in high school also. In high school also it is mentioned, but what we have read in school, no, that is sort of a basic thing. Okay, we cannot just stick to so much basic level for atomic models. This I am telling you based on the Hstr 2015 question paper. Okay, there is one question which comes from the details from Bohrs model. So what I have did is I have planned this class in such a way that we will discuss everything about atomic models in detail. Okay, especially the Bohrs model, because that is the latest model which is giving you the idea about how your atom is. Okay, it describes everything about the atom and the electrons which are revolving around it. So in this class I will discuss all the three atomic models: Thomson model, Rutherfords model and Bohrs model. But then I will go in detail into Bohrs model in the next class. Okay, in part 3 class of modern physics also I have made 2 parts. I have named it as part 3a and part 3b. Okay, so in this class, which is part 3a of modern physics, I am going to discuss the 3 atomic models, and in part 3b I am going to discuss Bohr's model in detail, and I will solve the important multiple choice questions based on these both classes. Okay, part 3a and part 3b. Okay, so this is the part 3a class. I will be uploading the part 3b class very soon. Okay, and part 4 class of modern physics will be the rest portion of this syllabus from this chapter. Okay, so as I was telling you, this is the right chronological order. What is the right chronological order? First Thomson's model came up, then Rutherford's model, then Bohr's model came up. Okay, so let us start with the Thomson's model. In 1898, scientist named J.J. Thomson, he came up with one model for atom. Means, see, you cannot see atom just like that, right? It is not easy to see an atom. But then, right from olden days, people came up with models which were gradually developed as days passed on, and as we know, the atom now is the result of all these models actually. Okay, so to start with J.J. Thomson, he was the one who started this. Means he was the one who gave the atomic model for the first time. He gave the model of the atom for the first time. Okay, so what did J.J. Thomson say? He said that positive charge of atom is uniformly distributed throughout the volume of the atom, as you can see in the figure, and negatively charged electrons, they are embedded in it. Now this guy Thomson, he was from England. That area of Europe, no, they had one sweet dish. Means it is like a cake, you can say. Their cake, the name of their cake was a plum pudding. So he compared the atom to the plum pudding dessert, and he told that whatever the cake part is there, no, that is all positive charge, and whatever the cherries are there, no, cherries or plums which are there, you can see that cherries in that cake, no, they are electrons, he told. Okay, what he told? He told that in that pie or in that plum pudding cake, entire of the cake is nothing but positive charge. He compared this plum pudding to atom. Okay, while comparing this plum pudding to atom, he told that whatever the portion of the cake is there, no, that is all positively charged, and whatever the cherries or plums are there, no, they are electrons, he told. Okay, that was his model. or in other words, if you want to compare it with something else, you can compare it with a watermelon. In watermelon, whatever the red part is there, no, that is all a positively charged part, he told, and whatever the seeds are there, no, those seeds are negatively charged electrons. This was the Thomsons model. Okay, you understand what he actually told, right? He told that those cherries or plums or seeds in the watermelon, they are electrons. The rest part is there, no, the cake part or the red color part in watermelon, no, they are positively charged portion of the atom, he told. Okay. This model was named after the popular dessert of that time, plum pudding model. Okay, it was known popularly as a plum pudding model of the atom. But unfortunately, this model landed up to be wrong because according to this model, number of electrons is less than number of protons, right? But we know that total electric charge in an atom is 0. Because if we touch something, we are not getting shock, right? Are we getting shock if we touch something? No, right? So it means that total electric charge of an atom should be 0. But then is it possible that total electric charge of this atom will be 0 if you have less electrons and more protons? That is not possible, right? That will be possible only when amount of negative charged plums will be equal to positive charged pudding part. Correct? So this drawback led to the failure of a Thomson's plum pudding model. Next, what happened is his very student Ernest Rutherford, he came up with a better atomic model. Along with his students named Giger and Marsden, he did one experiment. That experiment is famously known as Rutherford's Alpha scattering experiment or Giger-Marsden experiment. They did in 1911. Their idea of this experiment was that they focused one radioactive source on a thin metal sheet of gold. Okay, that radioactivity source emitted those particles known as alpha particles. At that time, they didn't know much about alpha particles, but now we know more about alpha particles. We will discuss about this also. But right now, let me tell you that they focused these alpha particles on one thin sheet of gold foil, and they made some boundary with a fluorescent screen also. With this, what happened? That alpha particles they hit on the metal sheet, and then those alpha particles were scattered. Okay. Now, why they used this gold foil only for this experiment means, see, gold, it is the most malleable metal and you can make it as thin as possible. Okay, you can make one thin layer using gold. You know what is malleability, right? The process in which metal can be made into thin sheets. It is known as malleability. So, gold is the most malleable metal. That's the reason why they used this gold foil as a thin sheet, and then they made this alpha particles incident on it. Then those alpha particles got scattered. Okay, this was the experiment. Now, what are these alpha particles? At that time, they didn't know what they are actually. They did not know much details about alpha particles. But now we know all the details. They are nothing but doubly ionized helium atoms. They have 2 neutrons and 2 protons, and they are positively charged particles. Because 2 neutrons and 2 protons, right? We are not talking about electrons. There are no electrons here. So, these are positively charged particles and they are doubly ionized helium atom. Okay. So, their atomic number will be 2 and the mass number will be 4. Okay. And these alpha particles, they are ejected spontaneously from that nuclei of radioactive elements. That's the reason why they used radioactive source there. And these alpha particles, they are having low penetrating power and they can travel for only short distances. Okay. Now, coming back to Rutherford's alpha particle scattering experiment, after that setup now, what happened in that experiment is, the alpha particles, many though went through the sheet, but few got deviated and very few got bounced back also. Okay, so this was very shocking for them. This was the result of the experiment. So after that observation, they came for some conclusions. So what were the inferences of their experiment is, they told that the size of the nucleus is between 10 to the power minus 15 and 10 to the power minus 14 meter. And then the scattering of alpha particle happened because of the encounter between alpha particles and the nucleus of the atom. And the size of the atom, it is around 10 to the power minus 10 meter, or around 10,000 to 100,000 times the size of the nucleus. Okay. And most of the space in an atom, it is unoccupied. That's the reason why alpha particles passed through that foil without any deviation. Okay. But few passed with the deviation and very few bounced back also, right? So with that observation, they told that there is a nucleus inside the atom. Okay. So for conclusion, what did actually Rutherford's atomic model tell? Rutherford's atomic model is also known as nuclear model of atom because it told that atom is composed of one central core which has a positive charge. And what is this central core? It is nothing but nucleus. So the most important point of Rutherford's atomic model is that it gave us the idea of a presence of a nucleus inside the atom. Next point was that negatively charged constituents are located around this central core. See, they are giving some idea about electrons which are present around the nucleus. Okay. And they also told that positive and negative charges balance with each other. So these are the three important points given by the Rutherford's team in Rutherford's atomic model. Having said all of this, there was a drawback that it couldn't explain why electrons and the positive charges in the nucleus, they are not attracted towards each other. Everything in the universe which is positively charged and negatively charged attracts towards each other, right? Even magnets do so, right? The South Pole and North Pole, they attract with each other. The reason behind no attraction between electrons and positive charge could not be given by Rutherford. So this became the drawback of Rutherford's model of atom, because it failed to explain why negative electrons did not lose energy and why they are not being pulled by the positive nucleus. Okay, because if the electrons, if they are moving like this around the nucleus, then at one point of time they should get exhausted with their energy and they should collapse right into the nucleus, but that is not happening. So this was the drawback of Rutherford's atomic model. Now answer to this question was given by Rutherford's student, another student named Niels Bohr. He came up with his planetary model of atom. According to him, electrons revolve around the nucleus in orbit just like planets are revolving around the sun. And then he told that we have this gravitational force, right, in the planetary system. Like that only, there is another force which is analogous to this gravitational force. The another force is there in between electrons and the nucleus, which you call it as electrostatic force. This is also inverse square law. Okay, this is also known as Coulomb's law, the Coulomb's force. Same thing like in the gravitational force, same thing is there here also. You have r square in the denominator, and here in gravitational force, capital G is the constant, right? Here in electrostatic force, K is a constant. That K will be equal to 1 upon 4 pi epsilon naught. Okay, and Q1, Q2 are charges. Here we are talking about electrons, so there will be 2 electrons in the numerator, means it will become E square. And R in the denominator is the distance between those 2 electrons. Okay, so this formula is important for us because we will use this formula and derive certain things. Okay, so Bohr's model or a planetary model gave more clarity about the atom. Here he told that the force of repulsion between atomic nucleus and alpha particle, it varied with the distance according to Coulomb's inverse square law. Okay, this is the formula or the inverse square law. F is equal to K into Q1 Q2 upon R square. Now before starting with what actually Bohr told, we need to understand few terms like what is called as a shell. There are 4 shells, right? K shell, M shell, L shell and N shell. In order if you go, they are K, L, M, N. We are talking about shells in an atom. Here in one shell, maximum electrons present will be equal to 2 into N square. What is this N? N is nothing but a principal quantum number. It is the maximum number of electrons that can be accommodated in a shell. So in K shell, you can have only 2 into 1 square or 2 electrons. In L shell, N is equal to 2. So you can have 2 into 2 square, that is 2 into 4 or 8 electrons. Like that only in M shell, N is equal to 3. You can have 2 into 3 square or 2 into 9, that is maximum of 18 electrons. Like that only in N shell, you can have maximum of 32 electrons. Okay, so the formula is 2n square. Now what is a shell? Shell is nothing but the pathway followed by electrons which are revolving around the atomic nucleus. Okay, so you should remember what is the meaning of this shell and what is this principal quantum number n, because we will use this now very frequently. Okay, now let's talk about what did the Bohr's model of atoms say. Electrons are revolving around the nucleus in some stable orbits. You call that stable orbits as the stationary orbits. Okay, now these electrons which are revolving around this nucleus in stable orbits, they are revolving without emission of radiant energy. Each orbit, it is having a definite energy, and this is called as an energy shell or energy level. Okay, the definite energy which each orbit is having, you call it as an energy level. And then he told that an orbit or energy level, it is designated as K, L, M, N shells, as I showed you previously. No, these are the 4 shells. When electron is in the lowest energy level, you say that it is in the ground state. Okay, lowest energy level means the electron is in the ground state. Energies of electron in an atom, they can have only certain values like E1, E2, E3 and it will go on. That is the energy is quantized. Means you cannot have any fraction. You can have only whole number. You can have 1, 2, 3, 4. You cannot have 1.5, 2.5 like that. Okay. So he told that energies of an electron in an atom, they can have only certain values. That is the energy is quantized. And electron emits or it will absorb energy when it jumps from one orbit to another one. Means from one energy level to another one. Okay, when it jumps from higher level to lower level, it will emit energy, and when it jumps from lower level to higher level, it will absorb energy. Okay, I will show this diagram and I will explain you. Okay, before that, let me tell you the 4th point of Bohr model. He told that the energy absorbed or emitted is equal to difference between the energies of 2 energy levels, E2 minus E1, and this is equal to h nu. So Bohr came up with atomic model relating to quantum mechanics. He related Einstein's and Planck's concept here. He told that E is equal to nh nu. Okay, h is Planck's constant here. Okay, and the change in energy means E2 minus E1 will also be equal to h nu. Okay, means it will be a whole number, it will not be a fraction. He told like that. Okay. Now let's see this concept of absorbing and emitting energy. You can see this figure here. If the electron is in ground state means lowest energy level, I told you, right? If the electron is in ground state and if it wants to go into the higher state or the excited state, then it will need some energy. So it will absorb energy. If the electron is coming from excited state to its ground state, then it will lose its energy. Means it will radiate energy or it will emit energy. Obviously, right, you have to imagine like if the electron is going from ground state to excited state, You imagine that the electron is going far away. At that time it will need more energy, right? So it will have to absorb energy. Okay, and vice versa, it will emit energy when it will come back to its place. Okay, so this is the Bohr's atomic model. Basically, he told that E is equal to NH nu. The energy of orbit is equal to NH nu, which is very, very important. Okay, this you should not forget. This can come as a direct multiple choice question in your examination. Now, as I told you, this delta E is equal to or change in energy is equal to E2 minus E1. This is equal to H nu, right? What is delta E? It is energy absorbed or emitted. What is H? It is Planck's constant. What is nu? It is the frequency of the radiation which is emitted or absorbed. Now here comes another important point which is known as angular momentum. Now because we are talking about the circular motion, right? The electron is revolving around the nucleus in a circular path. So we can bring in the concept of angular momentum here. This angular momentum is mvr, which is equal to nh by 2 pi. Okay, it is a quantized, you can say. N will be 1, 2, 3, 4 and so on. This will be the number of corresponding energy shell. Okay, here m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit of the electron, and h is the Planck's constant. Basically, Bohr's atomic model also tells that atom consists of a central positively charged nucleus, and it specifically says that electrons revolve around the nucleus in circular orbits, and outward centrifugal force, it will balance the net electrostatic attraction towards the nucleus. Okay, because of that the electron is not falling into the nucleus and nor it is going outside the orbit, correct? So that electron, it is revolving in that fixed or stationary orbit. Now what are these stationary orbits? These stationary orbits are those for which orbital angular momentum of electron is always equal to integral multiple of h by 2 pi. Means orbital angular momentum is equal to nh by 2 pi, where n will be 1, 2, 3, 4, so on. It cannot be 1.5 or 2.5. It should be 1, 2, 3, 4. It should be a whole number. Okay, that is what quantization means. Now these orbits for which mvr is equal to nh by 2 pi, these orbits are stationary orbits. Wherever the electron is there and the orbit is a stationary orbit, their energy is not emitted. Actually, Bohr took an example of hydrogen atom in order to make the assumptions of an typical atomic model. So we will have to study in detail about spectral series present in the hydrogen atom, and also we will be able to calculate different quantities relating to atomic orbit. Okay, so that I will do in next part of this class. Means it will be a modern physics part 3 class only, but I will name it as a B part. Okay, so this present class will be modern physics part 3A. The next class will be modern physics part 3B. That class will be the continuation of this class. Before signing off, I want to remind you all, if you are new to this channel, please do subscribe to this channel and also hit the bell icon, and also please share this class along with your friends and especially the Hstr aspirants. Okay, thank you. Bye.